One of the best projects that you can work on that has real legitimate potential to turn into $1 million SaaS has to do with web scraping. The ability to collect real-time data in industries like healthcare, real estate, and e-commerce is already a billion-dollar industry, and it's something that you can tap into with the exact project I'm going to show you today. Now, every great product should start with a problem, and a problem that I know exists today has to deal with YouTubers and sponsors. Now look, companies have massively scaled their social media spending, and influencer marketing is growing rapidly. With that in mind, companies want to know what influencers they can work with and what companies are already doing in the influencer marketing space. Now that's exactly where my idea comes in. Now, being a YouTuber myself, I deal with a lot of these brands and I can hear the pain and headache that they have to go through trying to find suitable influencers and also seeing which one of their competitors are working with influencers in this space. Now, that's why I came up with a relatively simple idea, but something that I think is so effective, which is a sponsorship detection and recognition system. Essentially something that can go and check any video or any person's YouTube channel and see all of the videos they've done that are sponsored and which company has sponsored them. With this type of system, companies can target specific influencers, look at all of the past videos they've done, whether they've been sponsored or not, and who's sponsored them. That way, if they want to take over an influencer, they could offer them more money, they can outcompete the other sponsors, and they can see exactly what other companies in their industry are doing. There's a lot more features that I want to build out here, but that's the general idea. And even for myself as an influencer, this would be super useful to be able to look through what all of my competitors or other YouTubers are doing and the type of sponsors that they're getting. So with that idea in mind, let me walk you through my planning process for building out this project. Now, step one, I need a way to collect all of this data. I need to collect a bunch of YouTube videos, probably based on some type of channel, and I need to grab their transcript, their description, the likes, the views, all of the metadata associated with that video. Now, once I have all of that information, which is not an easy task, I then need to analyze all of it and figure out if a video is sponsored or not. Now, I could just throw this to something like an LLM, but as you'll see in a second, it's not quite that simple. Now, once I've analyzed these videos, I then need to display this in some meaningful way, set up some different filters, allow companies to search, look by brand, look by creator. There's a lot when it comes to the presentation and being able to find information quickly. Now, this might seem kind of simple, but I promise you it is pretty complex, especially if we want to scale this and allow hundreds of thousands of people to be using this at the same time. So the naive approach to solve this problem would be to just simply use the YouTube API, maybe combine that with a custom web scraper in Selenium or Playwright, scrape all of the data we need from the videos, take the transcript and the description, throw it into something like an LLM, and then just ask it if the video is sponsored or not. Now, this will work on a very small scale, but as we start scaling up, there's two main issues that we're going to run into. Now, the first is scaling our web data collection and running into things like IP bans, and number two is LLM token limits. Now, unfortunately, I can't just hit the YouTube API thousands of times every few minutes, or even scrape YouTube myself using a custom web scraper, because eventually I'm going to get IP banned, I'm going to be blocked, I'm going to run into things like CAPTCHAs, because websites really don't want you to do this. They don't want to give you real-time access to all of their data. Now, even if I set up my own proxy network, I connect to maybe hundreds of different instances of scrapers, I'm rotating the IP addresses, I'm doing all of that kind of stuff, still eventually I'm going to run into problems. And even if this does all work, that's going to be a massive headache and nightmare for me to manage all of that infrastructure. And when it comes to the LLM token limit, even if I do collect all of this data, if I have a transcript that's 30 minutes long or an hour long or huge long descriptions, I don't want to pass all of that data to an LLM because one, it can't even handle all of that data, but two, even if it could, that's going to cost me so much money because you pay per token. So I need to think of a better way here that's actually going to scale up so that we can use this system, well, at scale. Well, of course, we have solutions to these problems, and for the first one of scaling our data collection, I can actually use something called a web scraping API. Now, these are designed specifically for this task and provided by a long-term sponsor of the channel and today's video, Bright Data. Now, they have all kinds of web scraping APIs here that allow you to collect thousands of results by hitting a single endpoint. They've got all kinds of web scraping APIs for all of the popular sites and resources that you would want to scrape, and these allow you to send a single request to an endpoint and have all of the complexity of scraping handled by Bright Data. So rather than creating your own network of scrapers, rather than writing your own custom code, code, you simply send something like the URL of a channel that you want to scrape, and it will return all of the videos and all of the data you could possibly want. So these are great. You can see that there's one specifically for YouTube, which is the one that I'll use in this video, and I'll show you more how it works later. But the important thing to understand is that behind the scenes, it does all of the web scraping for you. You just hit a single API, and then once the results are ready, it will deliver it directly to you. So that solves our data collection issue, but we still have the problem with the LLM token limit. Now, once I get all of these transcripts, I need to be a bit clever in how I pass them to an LLM. Ideally, I do want to use the LLM to verify that this video is sponsored and to extract what the sponsor is, because we don't really know in what format it will show up. However, what I need to do is make sure that I pass the fewest tokens possible, and here's an approach that I came up with that could definitely be improved. What I did is I came up with a list of about 50 different phrases that are very common to hear in a sponsored video. Things like sponsored by, brought to you by, in partnership with, all of these terms that you guys are very familiar with. What I then did is I searched through all of the transcripts of these videos and searched for the occurrence of that string. If I find that string, I then get the surrounding context. So for example, 50 words before and 50 words after. I take that context and I pass that to the LLM to verify if this does indicate a sponsorship and who the sponsor is. This way, we're 100% sure that a video is actually sponsored because the LLM is verifying that string, and we're using a much more targeted approach where we're only hitting the LLM if we find something that is likely to actually be sponsored. This will save us probably 99% of our cost and ensure that we are still getting accurate results. Anyways, that is enough talk. Let me show you a demo of the finished project and you can see what I built. So I've got the demo in front of me and let me show you how it works. So you can see that we have a bunch of URLs, titles, we have the views, the date posted, the status. This just tells us whether we completed scraping the video or not, because it can sometimes take a few seconds to get the result. And then we have the status of the sponsors, whether it's not sponsored or sponsored. If there are sponsors, it shows us right here. Now I just loaded in a bunch of videos from some popular channels like Mr. Beast, T-Series, Tech with Tim, of course. So you'll see as I go through here, we have like the creator on the side. A lot of them are Mr. Beast because I loaded, I think, 50 of those. This channel I found, this like car channel, Whistle and Diesel, you guys might have heard of that. And anyways, you can see as we go through here, it gives us all of the different results. Now, if we click into a video, you can see it shows us kind of a low res version of the thumbnail, the views, duration, date posted, likes, all of that kind of stuff, as well as some channel information, and then where it found the sponsor. So you can see here, it says Sweet James Accident Injury Attorneys. I don't know if this is a joke or not, or if this was a real sponsor, but either way, this is what the system picked up. And it shows us the kind of context of text in which the LLM analyzed and determined this was sponsored. So it says here is proudly sponsored by Sweet James Accident Injury Attorneys. I feel like this is some kind of joke for this specific video, but you get the idea. Then you can view the description and you can view the entire transcript. Obviously, we could improve the sponsorship detection, but you get the idea. If we look at my video, for example, Tech with Tim, you can see recently posted, found Parlet, misspelled that. It should be Parlint, which is the sponsor. But anyways, you get the idea and it found that. Okay, coming back here, again, we can look at a few more videos. And if we want, of course, we can search by the creator. So I can search by Mr. Beast and see all the videos specifically by him. I can search by a sponsor. So here's one that I have a lot of because I work with them for a long time, HubSpot. You can see now we have all of the HubSpot sponsors from myself, also one of my friends, Internet Made Coder here. Same thing, can click in the video, can see where it detected the sponsor, description, transcript, all of that kind of stuff. And then we can even, filter by sponsored or not sponsored to see all of just the sponsored videos, all of the not sponsored videos, etc. But the interesting part is how we search for videos. So let's say we have some video. I'm just gonna copy in one of these here. This is a Fireship video. I can simply put this here in videos. I can put a list of as many videos as I want and then just press on submit. Now I just need to wait, and then I can go to the end of the page and I should be able to just see the status of this video. Okay, so this is the video I brought in here, 17 weird new tech products at CES, okay, from Fireship, one of his recent videos. You can see this is sponsored by Brilliant, and if we click into here, it shows us exactly where it detected that sponsor from. Now that's fine, but sometimes I just want to bring in a bunch of videos from an individual creator. So if that's the case, I can just go to channel here, and then I can just copy the channel ID from YouTube, paste it here, and it will grab, I think right now I have it set at 50 videos, but it could grab all of the videos from that creator and bring them into the system. So So actually, when we go back here, you can see that it shows that this is pending. And what I'm able to do is just submit as many requests as I want, and they'll just get added to the queue and then processed and handled scalably. I'm going to talk to you about exactly how I do that in 1 second when we dive into the code. But the point is, I can just keep submitting requests. We then send that over to the Bright Data web scraping API, wait for the result to come back, and then process it. This way, I'm not actually bogged down here locally on my system. I can just keep submitting as many requests as I want. They get sent out to the cloud asynchronously, and then as soon as we have the results, we can display them. So I don't need to wait for this to finish before I can start kind of sending the request for the next channel. So while that's loading, I'll show you, this is where the request is actually getting sent to from my backend. So I have the front end send the request to my backend, then the backend send the request here to the Bright Data web scraping API. And you can see that it shows me all of the runs that have occurred. This is the one that I just triggered to run, where it's going to grab, I believe, 50 videos from the Fireship channel and then give me all of that information. So you can see all of the running times. And also, if I increase this to a lot more videos, I don't get a linear increase in running time. It does increase slightly, but if I collected 10,000 videos, for example, it's only going to be maybe 15 minutes to get all of those results, because we do scale this out and we run this in parallel on a ton of infrastructure. At least that's what Bright Data is handling for us, so that we don't need to do that ourselves, which is, again, very complex. Now, while we're here, I'll show you that if I go back to my scrapers here, you can see these are the ones that we've used. And actually, let me just go back to this page here. This is the specific one that I'm using, grabbing YouTube videos by post. We also can pass a channel URL here. And if we scroll down, it shows us all of the information that will be returned for every single video. So we get a ton of data here, not just the transcript, although you can see that right here. We get, for example, the quality, YouTuber ID, subscriber count, the comments. I don't think that one's working right now. Views, likes, video length, all of that kind of stuff. So that's how I'm kind of getting all of this data using this scraping API. And then I'm going to show you in a second how I analyze that with the LLM. Okay, so it looks like this is finished loading here. I know not all of these sponsors are correct, again, just because the system that I'm using here is not perfect. But you get the idea. We have a bunch of these Fireship videos pulling in all of this information. And if I want, I can click into any of them and I can kind of see the details and just verify that the sponsorship does actually make sense. Okay, so I'm in my code editor here and I'll give you a quick rundown of how the code works, but this is open source. I have it on GitHub and I'll leave that link below. Also, if you do want to try out the web scraping API from Bright Data, I'll leave a link in the description. You can click that and you should be able to get some free credits to be able to kind of mess around with that and see how it works for your use case. Okay, so let's get started here. I'm going to just go through my backend because the front end is really just displaying a bunch of stuff in React. I have a React front end and I have a fast API backend in Python here. And what I've done is I've just set up a few different routes. So I'll go in my main.py file here. You can see I have a bunch of functions, but the main ones we want to focus on here is the scrape videos endpoint, and then the videos endpoint, as well as the specific video ID endpoint, as well as pending channels. So these are the four main endpoints in my API. /videos simply returns a list of all of the videos. This has all of the query parameters, so sponsorship, sponsor name, creator, sort by, all of that kind of stuff, so that we can return the videos in a particular order and we can kind of filter them out. Obviously, there's a lot more filtering I would want to add if this was going to be production ready, but this is just meant to be a YouTube video, so I didn't go all out. Then we have scrape videos. This simply accepts a list of URLs, whether it is a channel list or a video list. And then what it does is it calls the handle URLs function, which is right here, where we handle processing all of the URLs. I'm not going to run through all of this line by line. Then pretty much what we do is we end up adding this as a background task in Fast API. Now it's very important that since we have an API here, all of the processing of our videos, we need to have that happen in the background in a different task or asynchronous kind of worker, so that we're not blocking requests to the API. A lot of people make the mistake of doing async operations in their main routes and not having it as a background task. If you do that, what's going to happen is you're going to be blocking your API from running. So because you have this other task running in the background and it's blocking, if I try to send a request to the API, I'm just not going to get any result back because I'm still processing this task in the background, or I guess not in the background if you didn't set it up this way. So Fast API actually has this background tasks kind of thing that you can use. I don't know exactly what you would call it, where I can add this asynchronous task to run and it will happen in the background in a separate thread and not block the main API. So that's pretty much what I'm doing here, handling all of these videos. So this is the process background task. And what happens when I process this background task is I go over here to this Bright Data API file. So here I just have the information about the web scraping API that I want to use. So the endpoint as well as the dataset ID, because there's various different data sets that I can hit. And then as I go down here, you can see I have an endpoint that simply checks the progress of my API. So Bright Data provides this kind of progress endpoint that will tell you when the snapshot of your data is ready. Because of course, what you're doing is you're sending an API request, and then it's going to take a second before you get the result. You can get the result back using something like a webhook if you wanted to do that, or you can have it sent directly to a database. But in my case, I'm just polling the endpoint using this progress endpoint here. And as soon as I know that I have the data ready, then I can download it, I can load it, I can do all of the stuff that I want to do in my backend. Then I have this function get snapshot data. So essentially once this is ready, which is what it's doing right here. So if the progress is completed, we're going to download all of that data or bring it in to our API. And then we're going to process it one by one and analyze that data for sponsors, because we need to first collect the data like the transcripts and the video information, then analyze the transcripts and find if we have sponsors. Okay, so that's kind of happening in conjunction with this process video data, where I'm doing all of this processing using a process pool. Now, again, because we want to make this as scalable as possible, I want to make sure all of these operations are happening in different processes so that we're not blocking our API and that we can run this kind of as quickly as possible. So rather than just using threading, which is going to run on one single CPU core here in Python, I'm using multi-processing. Now, this allows me to distribute the task of analyzing the sponsors of videos onto multiple CPU cores so I can really leverage the power of my system and do this as quickly as possible. You'll see why in a second, but pretty much once I have the data back from the API, I have all of this information about my videos. I now need to process that information and grab the sponsor data by using an LLM. So that's what this function does. Now it also uses something I created called a pool manager. Now this essentially handles kind of running the tasks on different CPU cores for me and ensuring that I'm not spinning up too many processes that I'm going to completely freeze and lag my system. So that's pretty much how that goes. We have some other stuff related to scraping the videos where we send the initial API request to start getting that data set prepared for us. And then all of the stuff I showed you up there is pulling the data set. Once it's ready, then downloading the data set. And then we get into the processing, which I'm going to show you now. Okay, so I have this pool manager. You don't need to worry too much about it, but it just makes sure that I have all of the different tasks that I need in a queue, and then that queue kind of sends the tasks to available CPU cores so they can start processing them in parallel. You see that essentially what I end up doing for every single task is processing the sponsor. So that again is going to involve looping through, looking for specific sections of the text that indicate a sponsor could be there, and then verifying that with an LLM. So this is my pool manager. And then I have my sponsor, parse sponsor script. So you can see I have some keywords. Obviously, I can add more of them. I also have an API key that I really shouldn't leak to you that I'm going to have to delete after. And you see that what I'm doing is I'm looking for discount code, brought to you by, affiliate, sponsored by, and I can add some more strings here if I wanted to improve the accuracy. Then what I do is I look through all of my text for a specific keyword. And then if I find that keyword, I grab 100 words, I believe, either before or after that specific keyword, and grab that as context so that I can then pass that to the LLM to see if a sponsor does exist. So here we have find sponsor, right? We have text, keywords. What we do is we extract content looking for every single one of these keywords that exist. If it does exist, then we add that to the context where we could potentially have a sponsor. And then what we're doing is we're using GPT-4o here to extract the sponsor name from that context if the sponsor exists. So you see that what I've done is I said, given this text, extract only the company name that is sponsoring or advertising. If there's no clear sponsor, respond with none. That's it. Then what I do is I just send a completion here to one of the new models from OpenAI, which is very fast, especially for small tokens. And you can see I kind of pass it in exactly what it's supposed to be doing, give it the prompt, and then it returns to me whatever the answer is. If it's something like none, no sponsor, unknown, whatever, then we return none. Otherwise, we return the sponsor name that it extracted. Okay, same thing here. We just have some logic for essentially running this for all of our different descriptions and transcripts. And that's how I'm parsing the sponsor. So that's pretty much it when it comes to the back end. Again, the basic flow is my front end. sends a request to the backend. The backend then sends a request here to the Bright Data web scraping API. You can see there's some documentation on how the APIs work. So the trigger is the first thing that we do, where I send a request to trigger the data set to start loading. Then I have some delivery options. So for example, I could have it delivered to storage, like an Amazon S3 bucket, Google Cloud Storage. I can have it delivered via a webhook if I wanted to do that. We also have a notification URL, so we can notify us when we can download the data set, or in my case, I just pull the endpoint constantly until I get the result. So that goes into the management APIs here, where I can get a list of the snapshots, and I can also monitor the progress, which is one of those API calls that I was using in my backend. Obviously, there's a lot more going on here. You guys can read the code if you want, but I wanted to give you a quick demo and explain to you how I set up this project and how I actually allowed it to scale. This is a really interesting project that I think would look fantastic on a resume and that could actually become really $1 million SaaS. This is super useful. Obviously, what I have is not quite finished, and you want to really build this out and spend a lot more time on it, but I hope I inspired you guys with a cool idea and that you'll try building something like this in the future. If you do want to try out these web scraping APIs, again, they are super useful, especially if you want to collect a lot of data at scale and you don't want to deal with the headache of constantly having to manage the infrastructure, manage a ton of different requests, proxy networks, all of that kind of stuff. This just gives you pretty much exactly what you want from a lot of different sources. And again, all you have to do, send the request, get the data back, and then process it as you would, so you can focus on development, not web scraping, which generally is a bit of a pain. Anyways, if you guys enjoyed this video, make sure to leave a like, subscribe to the channel, and I will see you in the next one.